So let us redo this question. In the previous video, we made some mistake, and here is the correct version. The rest was were fine. We made a mistake on part B. So let's redo it. Okay. So this is a network of resistors. So we have current entering here, and then it branches off. Okay. So it branches off there and off there, meaning there's a part of current going there, and there's a part of current going in that direction. So to know properly this easy, let's add these two because these two are in series so that we can have a parallel connection. Meaning if we add these two, we'll be having a situation like this. Like this. Okay, then that's the current going out. Meaning this was also the 6, and this is also what? The 6 ohm resistor. Now these two are in parallel connection. Meaning the current, once it reaches here, it branches off and branches off like that. It's the same concept here. So because there's equal resistance, all right, here and there, meaning it's just branching in half. So the current in the 6 ohm resistor will be equal to the total current. We divide by 2. That will give us what? 3 amperes. What charge passes through the 6 ohm resistor? Okay, well, charge is given by current. We multiply by what? Time. Since the time is already in seconds, there's no problem there. Our current now is our 3 amperes there, multiplied by 3, giving us 9 coulombs. What is the potential difference across the 6 ohm resistor? Potential difference, which is just voltage, by the way, well, it will just be given by what? The current multiplied by what? Resistance. And we know that the current in the 6 ohm resistor is actually 3 amperes. We multiply by the resistance of itself is what? 6. That is going to give us what? 18. Volts. Okay. Part B is a 2 kilowatt. The word kilo means 1,000, meaning 2 kilowatts is the same thing as 2,000 watts. Take that into consideration first of all. 250 volts electric fire is connected to a 250 volts mains. How much current does the electric fire take? Now we've got power and voltage. We know that power is voltage multiplied by what? Current. So if we're looking for the current, meaning our current will be equal to the power over voltage. Our power is 2,000 watts. Our voltage is 250. So get yourself a calculator there. So 2,000 we divide by 250. Should be 4 somewhere there. 8 what? Amperes. The other one says, what is the cost of running the electric fire for 5 hours if the cost of a unity, which is a kilowatt hour of electric energy, is 900? So the cost of electricity is just given by, number 1, energy. Then the energy multiplied by what? Unit cost. That's all. So the question is, how do we find energy? Remember that energy is what? Power multiplied by time. So here we are talking about power multiplied by what? Time. Then multiplied by what? Unit cost. So the power, we already have it in kilowatts, so don't even worry about it. So just multiply 2 kilowatt multiplied by 2 kilowatt, we multiply by time, should be in hours, 5 hours. Then that is being multiplied by 900. So let's go on the calculator. So 2 multiplied by 5, then multiplied by 900, which just give us what? 9,000 kwacha as the total cost. All right, so thank you so much, and the correction has been made now.